Okay, starting 1000. Okay. So we're starting from question 1. Which reads, this is 1A. Write 2.517 in the form A over B. Of course, where B is non-zero, A, B are integers. So how do you do that? Obviously, you know as you enter the exam room, these are the easy questions you're expecting before you expect of hard questions. So on the easy ones, you must get them correct before you think of getting the hard ones. So in this case, what do you do? First, you let, say, x be equal to 2.517. To put a bar there. What next? You want to put the like terms together. The numbers that do not have a bar on top, you put them together. Now, how do you move a number across the point? You use the zeros to multiply. So in this case, you count how many numbers are not under the bar and yet are after the decimal point. We only have one, that is 5. So we have to multiply this whole equation by 10. So we have 10x is equal to 25.17 bar. Okay. Then this is what becomes our first equation for now, because it's in the standard form. All the numbers before the decimal point are under the bar, and are not under the bar, and they're the only numbers that are not under the bar. So you require that on the right, you should have the numbers under the bar. So next we count how many numbers are under the bar. We have 2. So what does that mean? We'll have to come back and multiply this now by, multiply everything by 100. So we are multiplying 10 times 100 to get 1000 x. When you multiply this by 100, the 2 decimals will move 1 step to the left, and then we remain with same, because bar means 171717. So when you just move 17, you still have so many 17s that you can just put under the bar to mean at the same thing. So this was our equation 1. Now we have our equation 2. It was equation 1 before we multiplied by 100. So now when we say equation 2 minus equation 1, we mean 1000 x minus 10x is equal to 2517.17 bar minus 25.17 bar. Okay, so you do 1000 minus 10, we get 990. X is equated to 2517.2517.17 bar minus 25.17 bar. So this is 0 here, 0, and then 7 minus 5, we get 2. And then from there, we borrow, we have to do 11 minus 2, that's 9, and then 4, and then 2. So we get 2492. And then divide by 990, divide by 990. So x is equal to 2492 divided by 990. I'm sure here we can use 2. I'm sure here we can use 2 to reduce. So if we use 2 on top, we'll have 1, 2, and then 2 into 9, that's 4. Remainder 1, making 12, so that's 6. Over 2 here, that's 4. And then 19, that's 9. And then 5. So I think we can leave it here like that. Now, are you able to get me?
Yes, sir. Yeah.
Oh, good.
Yes, sir.
Okay, wonderful. So every time you are given this question, so these are questions that we are expecting in the exam. You only have 2 types. This type where you have a number not under the bar, and the other type where they may put all the numbers under the bar. If all the numbers are under the bar, when you say let this be x, the next thing you do is you multiply by the numbers that are under the bar. How many are they? There are 3. So you multiply by 1000. Multiply by 1000. So you're going to have 1000 x is equal to 2517.517 bar. And then you're subtracting now this 1000 x minus x is 2517.517 bar minus 2.517 bar. That's how you subtract. Okay. So notice when to use this, the given one, as your x to subtract here, and when to use the one that you've multiplied to subtract. You always want to subtract the equation that is in the standard form. Standard form meaning the numbers after the decimal must all be under the bar. If there's a mixture, then you move to the other side. Okay, you cannot have something like this where the number under the bar is inside. This can't be there. What you should have is this case or this case. All questions of such nature will only come in 2 ways. Whether they put a minus or not a minus, this is the same standard. Unless one has a question on this part.
So I have a question.
Please ask.
Yes, okay, no, it's not a question involving this, but like, since seeing that we're not doing topics like statistics and probability, are we going to be allowed to use calculators in the exam?
No. It has to be everything. Okay, so there's a question that what do you do to those numbers that do not have a bar? For example, express 2.517 as a fraction. Okay, in the form A over B. How do you do that? These you just count, you just do over. You're placing a 1 here, and you know you have a 0, 0, 0. So you can easily write your number 2517 over 1000. This should be X. That's how you simplify those that don't have a bar. There is ones, you just a step. Hello.
Are you dividing the 1000 because the numbers after the decimal point are 3?
Yes.
Okay.
There's a question saying, what of where there is 2, put a 0? It's the same thing. It's the same thing. If there's 0.2, I mean 0.517, and there's a bar here, we'll treat this question the same way I've solved the one where there was 2. 0 is just a number as well. Okay, so if 0 is standing there, we are still counting how many decimals we have. The first step, you multiply by 10. So now you have 5.17 bar. Then multiply by 100. So you do the same thing. Whether it's 0, whether it's -2, you are treating the question the same way. No variations there. You still subtract. Okay, if it's a negative, what do? You still subtract. Because when you subtract, you're going to have negative plus, meaning you're doing a subtraction. Okay, so in this paper, we have made a positive 1. We've commented on the negative, on the 0. What if there's no bar? Maybe in the next paper, we'll make the one that will have a negative, or whichever form it will be. We'll also talk about it. Though there we'll talk about it less. Maybe we'll just do the first step and then we'll say we can now connect. I expect you to solve this question again and then think of what can happen if they don't bring this exact question. That's how you prepare for exam.
But if we think of what, sir?
You think of, as you solve this question, you think of it as, what if it was negative? Could I still get the answer? You try to solve if you have difficulties. You solve. You can try as you solve, right. You say, okay, what if I have this? We've commented on it here. Can I reach the answer? You try and see if you can reach the answer. You check in the tutorial sheet. What questions were there that were funny around this concept? You tap a bit and then move on.
Exactly, sir.
Okay. We go to part 2. Part 2, we are given Z as 3 plus I over 1 minus I. The question says, find Z minus 1 over Z. Okay, in the form A plus BI. So find Z minus 1 over Z. Well, you are given the Z to use in this expression. Don't say where is Z. Z has been given. Okay. So, well, this is going to be Z minus 1 over Z is equal to 3 plus I over 1 minus I minus 1 over 3 plus I over 1 minus I. So what happens? This will be 3 plus I over 1 minus I minus. We rewrite this part here. We write it. You always think of it as A over B over C. If it's the situation, when you change from a division, in fact, you can write this as A divided by B over C. This is just like A over 1. Okay, you may wish to change from division to multiplication by switching the right. This will just be AC over B. Now from this, when you get back here, you say, okay, so this will be 1 minus I over 3 plus I. Fraction. Okay, now it's a fraction. What do we do? We put together the common denominators. So 1 minus I is being multiplied by 3 plus I. And then when you do that, we have 3 plus I multiplied by, when you divide this into the denominator, you get 3 plus I. Minus, you have 1 minus I. And then 3 into this, you get 1 minus I. So what we get, we expand. 3 times 3, we get 9. Plus 3I. Plus 3I. Minus 1. Which one is minus 1? I times I. Because I times I is I squared. And I squared is negative 1. This one you should never forget. I squared is negative 1. I itself is the root of negative 1. That's why when you square, you get negative 1. And then minus, we're now dealing with these two. So open 1 times 1, we get 1 minus I minus I. Then negative times negative for the i's becomes positive. Then I times I gives us a minus 1. And then everything we divide by, we're also expanding down. So 1 times 3, we get 3 plus I minus 3I. I times I is negative 1. Then there's a negative there times positive, that is negative. So negative times a negative from i's, so get a positive 1. And then we're now adding, so 9 minus 1, we get 8. 3I plus 3I, we get 6I. And then minus 1 minus 1, that's 0. And then negative I minus I, that's negative 2I. That negative is coming here. So I now multiplying negative times negative. So we'll have positive 2I. Then down 3 plus 1, that's 4. And then I minus 3I, that's minus 2I. This is 3, and that is 8 plus 8I over 4 minus 2I. Ah, I'm too fast. So where are we? Where have you left to?
Sir, you are very inavailable.
I'm very fast. You guys, you are teasing me.
So I want that negative 1 disappear too.
What do you mean negative 1?
How did you remove the fraction?
How did you?
How did you remove the fraction, like from the first step?
Okay, so let me start from here. If I have A over B, and I'm dividing by C over D, you can choose to write this as A over B divided by C over D. You may also choose to write this as A over B multiplied by D over C. If you change division to multiplication, you switch C and D. D becomes the numerator, C becomes the denominator. Then this is going to allow us to say AD over BC. So you can change division to multiplication, provided you interchange. I remove this now. I bring 1 over, in brackets, 3 plus I over 1 minus I. This is the same thing as 1 divided by 3 plus I over 1 minus I. I can choose to change this division to multiplication by saying this. When I change multiplication, I interchange, so I have 1 minus I over 3 plus I. But 1 multiplied by anything, I get that very thing. Like that. So where has the 1 gone? Are we seeing where the 1 has gone?
Yes.
Okay. And that's how the fraction has changed from being 1 over 3 plus I over 1 minus I to being that thing here. From there now,
Right,
so from there now you get the common denominator. How do you get the common denominator? Because we have 2 fractions. You multiply the 2, their denominators. 1 minus I multiplied by 3 plus I. Then you are dividing this whole denominator that you have called the common denominator now, divided by the first part, denominator. It will take away this. It will remain with 3 plus I. That 3 plus I will multiply the numerator of 1 minus I, which is this one. That's why we're having this multiplied by itself. It's coming from that. And then minus, you're now dividing this into this whole thing. It will take away this. So the numerator of this one, which is this part here, we multiplied by what we get here, which is this. That's why we are seeing this multiplied by that. Okay. Then you start expanding. So how do I expand? 3 plus I multiplied by itself. You're just doing 3 times 3, you get 9. 3 times I, you get 3I. Again, I times 3, you get 3I. Then I times I, that's what I was saying. I times I is -1 So you would get -1. That's why I have this -1. And then minus, open. 1 times 1, you get 1. 1 times -i, you get -i. Again, -i. Then negative times negative, it's plus. I times I is -1. So this has given us this -1 here. You divide by, you expand this as well down here. So 1 times 3, you get 3. 1 times I, you get I. Negative I times 3, you get -3i. Negative times positive, you get minus. And then I times I, you get -1, which makes this positive. Like that. Then from there now, you get to this 9 minus 1, 8. Which one? This one here. Then inside the brackets, we have 1 minus 1. That's 0. So there's no constant that is coming out. What do you remain with? You remain with -2i. -2i times this negative here becomes +2i, but it's here. -2i times the negative. So this becomes +2i. +2i plus 6i, we get 8i. The question says in the form a plus bi, meaning we have to conjugate now. To conjugate, you multiply the denominator by the very 4. Now you put plus 2i. You do the same in the numerator. So what we get? 8 times 4, we get 32, plus 8 times 2, we get 16i, plus 8 times 4, you get 32i. And then 8 times 2, we get 16. I times I, we get -1. Then we divide by 4 times 4, we get 16. And then 4 times 2, we get 8i. -2 times 4, we get -8i. And then -2 times 2, we get -4. I times I, we get -1. So -1 times -4, this becomes positive. And then now you have 32 minus 16, that is 16. 16 plus 32, that's 48. I. 8 minus 8, that's 0. 16 plus 4, that's 20. So I'm putting 20 here and also 20 here. Maybe we can simplify further. We divide by 4. 4 into 16, that's 4. 4 into 20, that's 5. Plus 4 into 48, that's 12. And 4 into 20, that's 5. I. So this is the solution. You can put I anywhere except in the denominator. If you want, you can write I as 4/5 plus 12i/5. This is the same thing. Is it okay?
Yes, sir.
What if you have I power 3? I power 3 is I times I times I. So I times I is -1. Times I is -I. Okay, so remember what I said, that as we revise for the exam, you may not have all the videos on YouTube. This will be the last video I'll post on YouTube. The other videos starting the next one that is coming after we log out, I'll post you maybe on a different YouTube, which is not too public, so that becomes for a small domain. Many of you are complaining that because you have paid for this, it should be yours alone. So it will be yours alone, don't worry. Okay. So you're logging out and quickly get back. We have to do at least 2 questions today from this paper. I think we'll do 3. So we'll log back and see how far we go. Okay, let's log out and come back quickly.